All right, we're going to continue here with looking at some extraneous solutions and getting some practice for the quiz tomorrow. Okay, so an extraneous solution. So the definition, we've seen this already, it's an invalid solution that may arise which satisfies a transformed equation but does not satisfy the original equation. We saw this with Megan's solving of an equation in the previous lesson during that task problem. She solved and got a solution of x equals 1, but when she looked back at the original equation and substituted that in for x, she got a bunch of undefined values. The denominators became 0. And so this can occur when the denominator is eliminated while solving, right? Our goal to get a common denominator and then multiply by that denominator eliminates the denominator. So that destroys the part of the equation which would become undefined, and that's why we get a solution that seems right unless we actually go back to the original equation that has those denominators in them. And so this is why we must check that our solutions are valid using the original equation. So these two you want to add to your definition of extraneous solution and combine these with your key points to make sure you have a plan of attack for when you're solving rational equations. You want to make sure that you know what steps you need to take in order to get a solution and then to check that your solution is valid. All right, let's go ahead and take a look at a couple problems that you can use as some practice. So here are 3 equations that you can solve for the given variable with, and you want to verify that each solution is valid. So go through, and I'm not going to give you the answers here because you can actually check that each solution is valid. So go ahead and do so, and if you get stuck at all, I'm going to, in about 5 seconds, give you a couple tips for each of them that might help you out a little bit. All right, so hopefully that went well. If you need a couple of hints here, the big picture is that when we're solving for a variable, as we are in each of these situations that involve rational expressions, we'd want to eliminate the denominator so that we can just solve an equation that's much easier to work with. And so to eliminate that denominator, we need to get a common denominator amongst all of the expressions. So one helpful tip is to factor the denominators so that we can see which factors each one needs. So for example, this factors, and this is 3 times x times x, so we can see that this will need a 3x and this will need an x. Similarly here, t squared minus 2t minus 3, that factors as well, and into 2 linear factors. And then over here, again, we have an x squared minus 6x plus 8, which will have 2 linear factors. So factoring will help you see what that denominator needs to be. And then you also want to make sure that you are multiplying by a form of 1. So what I mean by that is when you're finding a common denominator, and then you want to make, for example, this denominator 3x squared, you need to multiply the numerator by the same thing that you multiplied the denominator so that I don't change the overall value of each expression. All right, take your time, be neat, and tomorrow in class, be ready with some questions or some solutions or a little of both.